Example 3. Consider the reaction 2 mole of aluminium reacted with 3 mole of chlorine produce 2 mole of aluminium trichloride. A mixture 2.75 mole aluminium and 5 mole chlorine are allowed to react. Determine the limiting reactant. Okay, so we proceed to our first step to determine our limiting reactant. Okay, so the first thing we label the mole of aluminium and chlorine. So our mole is 2.75 mole, and for aluminium is 5 mole. So the mole both given are labeled as a available mole. So if we reacted together, we must be identify who is the limiting reactant. We need to make a comparison in stoichiometry. If we have 2 mole aluminium reacted with the 3 mole of chlorine, so if we have 2.75 mole aluminium, so it's equivalent to 2.75 times 3 over 2, so it's equal to 4.125 mole of chlorine. So we label as a needed. And what should you do next? You must be compare the needed and available mole. So therefore, the needed mole is the smaller than available mole. So therefore, aluminium we can label as a limiting reactant because the needed is smaller than available mole. So you can make a conclusion: mole chlorine needed smaller than mole chlorine available, thus aluminium is limiting reactant and the next here is chlorine is excess reactant. So we proceed to the second question. How many mole of chlorine form? How many mole of aluminium trichloride form? So you must be compare mole of available aluminium compared to the mole for our product form. So 2 mole of AlCl3 from equation 2 mole aluminium can be produced 2 mole AlCl3. So available mole aluminium is 2.75 mole of aluminium. So therefore I can find 2.75 times 2 over 2. So we can get the mole of aluminium also 2.75 mole AlCl3. So the target question, how many mole? So 2.75 mole is our final answer. Similar or not of our final answer, 2.75 mole, also same. So C question, how many mole of the reactant remain at the end of the reaction? So target question is reactant. So who is the reactant? remain at the end of the reaction, it must be labeled as a chlorine. So what should we do now? You must find out the remaining mole. So available mole of chlorine is 5, but needed is 4. So therefore we have a remaining mole, right? So what should you do next? You must find out the remaining mole for excess reactant. So equation C, mole reactant remain. So therefore this is a chlorine molecule. So we have available mole is 5.0 mole, needed mole, so 4.125 mole. So we have the excess mole here. So mole excess, and find 5 minus 4.125. So therefore we can find the remaining mole is 0.875. So the question, how many will remain at the reaction? So this is our final answer. Okay, so we proceed to the second question. If we have the silver nitrate, zinc reacted with the silver nitrate according to the equation given. If they are given the zinc in the form of mass and also the silver nitrate in the form of the mass, determine the unit reactant. So the first step also same. So the first, you must find out the mole available for both reactant first. So mole zinc. Two 2.00 gram over molar mass zinc 65.4. So therefore the mole is equivalent to 0.0306 mole. So next you must find out together mole of EG3. So the mass given 2.54 gram over. So molar mass of silver nitrate is 107.9 plus 14 plus 16 times 3 gram per mole. So therefore this is equivalent to 0.0157 mole. So the both mole we can label as a, so they we can label as a available mole. So what should you do? You must find out the mole of needed. So from the equation we have 1 mole zinc reacted with the 2 mole silver nitrate. So the mole of zinc available is 0.0306 mole of zinc. So therefore you can get 0.0306 times 2 over 1. So this equal to 0.0612 mole of silver nitrate and we label as a needed mole. So we must compare Compare of what? Needed mole of silver nitrate and available mole of silver nitrate needed down. So therefore, we find out the mole of needed silver nitrate is larger than mole available 0.147. So zinc become our excess reactant. So we can conclude that mole silver nitrate needed larger than available. So therefore, zinc is excess reactant. While silver nitrate is limiting reactant. Next, for the second question, calculate the mass of silver form. So therefore, by using our limiting reactant, 2 mole of silver nitrate produce silver. 2 mole of silver. By using available mole of silver nitrate 0.0147 mole. So therefore we can find mole of silver 0.0147 times 2 over 2. So therefore we can find the same answer 0.0147 mole of silver. So the target question is mass. So you just make a relationship mass and mole. So mass for silver equal to 0.0147 mole times molar mass of silver 107.9 gram per mole. So the mass for silver 1586 gram. And for the C question, how many grams of the excess reactant will be left at the end of the reaction? So, who is excess reactant? So, our excess reactant is zinc. So, kita find out the available mole of zinc is equal to 0.0306 mole. So now we need to find out needed mole of zinc. So by using the stoichiometry, we compare the limiting reactant to the excess reactant. So 2 mole of silver nitrate reacted with the 1 mole of zinc. So by using available mole 0.0147 mole of silver nitrate, so 0.0147 times 1 over 2. So we can get the mole for here is 0.00735 mole needed. Belong to the zinc. So you can find out the mole excess mole of zinc is equal to 0.0306 minus 0.00735 mole. So therefore equal to, so the mole remain is 0.02325 mole, and we just make a relationship mole with the mass. So mass of zinc equal to 1.52 after you already got that time with molar mass of zinc.